Those are online. Is my voice audible?
Yes, sir.
Okay. Just I need 2 minutes break down. I'll just be back. I'll have some water and come. Keep revising the concept of Kirchhoff's law. No? Just go through the concept once. We'll start with problems. Just go through them. Yeah, those are online. Am I audible? Yes, sir. Okay, we'll get started. So we'll start with this problem. Problems based on Kirchhoff's laws. So the first question is, determine the current in each branch of the network shown in figure 3.17. And there is an NCERT example 3.6. Okay. So listen to this. There is a network of this format given in which we are interested to find the current that is flowing through each branch. Okay. So first point to be noted is, since there is an example problem, they have given you the directions and the values of current. Generally, they will not give you. Okay. So whenever you say Kirchhoff's laws, it is both the laws applied in the same problem. That is the first point you need to make a note of. Okay. And if you look at this question, right, you have two cells. So you have two cells and multiple resistors, due to which you have a network which is formed. So in this case, if you ask me, is it easy to apply Ohm's law? I would say no, because we need to make them as one cell and then make them as one resistor. You need to find the equivalent value. It is slightly a complicated process. So we need to go with Kirchhoff's law. So how to solve? Let's see. So look at the values of EMFs of both the cells. So among two, which one is having higher value? It is the left one, which is 10 volt. So we'll start solving the problem from there. So let's say 10 volt is supplying a current of I1. That I1 is flowing towards the junction A. So from there, what will happen is the current will start getting split, because that is the one which is supplying the energy to the remaining part of the system. Right. So from I1, if I say the current that is flowing in the upward branch is I2, so out of I1, how much is lost here? I2. So the remaining current should flow at the bottom. So I1 minus I2 will flow here. Okay. So this I2 is going to the point B. It is going to the junction B. So at this place, what will happen is, let's see what is going to happen. There are two ways to analyze this. One is you can say that the current from here is getting split into two different branches, or you can start from the bottom also. So I am going according to the way they solved it. Okay, the way they have given current, so that you will understand. So if I take this to be I1 minus I2, then this I1 minus I2 is going towards the junction D. So from this junction, I3 is flown in this direction. So from I1 minus I2, I3 is going here. So the same I3 is going to reach the junction B. Am I right? Because it is flowing through the cell. Is it clear till this point? So I3, and here also you have I3. So at the junction B, what is happening is I2 is coming, I3 is coming. So according to Kirchhoff's current law, what should happen? The sum of the currents entering the junction is equal to the current that is leaving the junction. So this I2 and I3 will get added and they start flowing from B to C. Clear with this? So what is going to happen at this junction C is, observe, I2 plus I3 is coming here, but already I1 is flowing away from C. So how much will be the remaining current that will flow from C to D? I2 plus I3 is the input. From I2 plus I3, I1 is lost. So how much will come down? I2 plus I3 minus I1. So that is the one that is going to come down. Am I clear? So that is why the values are taken in this way. So I'm purely going with the way they have taken the current. I hope you're able to understand this, right? Now, so since our objective is to find the current in each branch, right? Our objective is to find the current in each branch. First thing that we need to know is how many unknowns are there in the problem. So how many variables did we introduce? I1, I2, and I3. So first point to be noted is number of unknowns is equal to the number of loops we need to consider. That is the first thing. Am I clear with this point? Secondly, when I say the number of loops, right? So when you take a loop into consideration, there might be a situation where the loop might not consist of any cell at all. So just for you to understand, let's say there is a circuit like this. When I say a loop, it should have the same starting and the ending point. For example, if I look at this problem, it will be AB. Let me call this point as D. So ABDA is one loop. Suppose I say this problem has three unknowns. So how many loops do I need to consider according to the statement I made? 3 loops. So out of those 3 loops, if I take the loop ABDA, for instance, okay, if I take ABDA, this loop does not consist any cell at all. It consists only of resistors. Similarly, the other loop that I can consider is BCDB. If I take that, there also there is no cell, right? So I can take the third loop as ABCDA. ABCDA. If I take it like this, there also there is no cell. So whenever you are considering the number of loops, you need to ensure, you should not make this mistake. You need to ensure that at least one of the loops is having a cell in it. You should not take all the 3 loops without the cell. You will not get the answer. Because when you solve these 2, you will get the third expression. You will not know how to solve it. That is the reason. Right? So that is the second point I would like to stress upon. At least one of the loops considered should have a cell present in it. Is the point clear? Right? So these are the 2 important conditions that we need to have in our mind when you are applying KVL. Because you speak about loops only when you apply Kirchhoff's voltage law. So if you observe, when I say Kirchhoff's law, I repeat it, both the laws are simultaneously applied in the same problem. It is not like you will have individual application of it. Am I clear with this? Yes. So having said this, since we need to consider 3 loops, I will tell you how to consider them and write the equations. So if I take the loop ABCA, then when I go from A to B, then I am crossing across what kind of an element? I am crossing a resistor. So whenever you cross a resistor, when you say Kirchhoff's voltage law, the expression should always be in terms of potential difference. So across the resistor, how is the potential difference defined as? V is equal to IR. So you know the resistance here and you know the current that is flowing through it. So how much is the value? It is going to be 4 times I2. Now it is time for us to decide the sign. So what is the sign convention telling us? When you move from higher to lower potential, you take a negative value, right? So whenever you encounter a resistor, one thing that I would suggest you to have in mind is, if you are walking in the direction of current, see, current is from A to B and you are also walking the direction from A to B. If you are walking in the direction of current, you take it to be negative. Okay. Now, if I go from B to C, what is going to happen? So it is 2 times I2 plus I3. Again, you are walking in the direction of current, so you take a minus sign. Similarly, you go from C to A. You encounter 2 elements. What are they? One is a resistor and one is a cell. So the concept of looking at the direction of current or in the direction opposite to current is applicable only for resistor, not to cell. Right? So when you walk from C to A, when you go across this resistor, what you need to do is, resistance is 1 and the current through it is I1. Next, you need to check you are walking in the direction of current, so you take a minus sign. Whereas across the cell, what you will do is, you will only check whether you are going from lower to higher or higher to lower potential. So when you move from C to A, you are moving from lower to higher potential. So you take plus 10 and the sum of all these things put together will be equal to 0. In the direction of current. A to B is in the direction of current. In the direction of current, negative for resistor. So in the direction of current, you should not see it for a cell. Don't make that mistake. Because for the cell, you are walking from lower to higher potential. When you go from bottom to, when you climb the stairs, positive. When you get down the stairs, it is negative. That is the logic. Am I clear with this? Okay. And listen to this. One more important point I would like to stress here is, when you take a loop, you should always count the number of elements that are present in the loop. How many elements are there? 4. 3 resistors, 1 cell. So 4. So the number of terms in the expression should be 4. 1, 2, 3, 4. And second point is, when you write it, you need to ensure at least one of them is having the opposite sign. I gave you the logic already, because the sum of all negative values or sum of all positive values can't be 0. Right? That is the reason why you need to have opposite signs. Is the point clear? So make a note of this. You can take, they have taken it like that. That is why I explained with it. They have taken it like that. Had I taken it, maybe I would have taken in the reverse. Okay. That is why I told you in the beginning of the problem itself, I'm going with the way they took the current. I'm not changing anything in it. For next problem, I'll give you the freedom of taking. You do it in your way. எங்க I1? அது minus I1 ரா, ஏன்னா நீ C2A போறல்ல. அவங்க எடுத்துட்டாங்கடா. நான் தான் சொல்றேன், nothing is taken by me, it is refilled. டயக்ராம்லயே கொடுத்திருக்கு. ஏன்னா இது எக்ஸாம்பிள் ப்ராப்ளம் இது. ஆமா, 10 is what? That is only for resistors. Simple ரா, resistors வந்ததுன்னா you will write I into R. வெறும் பேட்டரி இருந்ததுன்னா you will write that voltage. So அந்த 10ன்றது வோல்டேஜ், அப்பதானே இது டைமென்ஷனலா கன்சிஸ்டன்ட். எப்சிலான் is EMF. Okay, am I clear with this? Is everyone clear? Will you be able to do it on your own? Now I'm going to give you another loop from the same question. Now you are going to try writing it. Okay, so the next loop that I'll give you is DC AD. So for DC AD, frame the equation. For DC AD, you are going to frame the equation. How will you do? So when you go from D to C, right? When you go from D to C, you're walking across a resistor. So for resistor, what are you supposed to do? Take the resistance value, multiply it with the current. So how much is the current across this resistor? It is I2 plus I3 minus I1. So I2 plus I3 minus I1, but it is going to be plus because you're walking in the direction opposite to current. This plus. Am I clear with this? Secondly, when I go from C to A, you are walking across a resistor and a battery. So across the resistor, what is going to be the value? It is I1 into 1, right? And it is going to be a minus. I1 into 1 is going to be a minus. Why? Because you are walking in the direction of current. When you go from C to A, you are going in the direction of current. So this one, across the battery, what did I say? You need to take only the voltage into consideration, and you move from lower to higher. So it is going to be plus 10. And when you go from A to D, minus 4 into I1 minus I2, everything put together will be a 0. So all that you need to validate is opposite signs. Secondly, you need to count the number of terms, number of elements and the number of terms. 1, 2, 3, 4. 1, 2, 3, 4. Clear? Right? Right? Shall I proceed? So the next one is you can take the third loop in whatever way you want. See, if I take this point to be E, for instance, then I will take the third loop as AB, ED, A. I'll take it as AB, EDA. So all that you need to do is you look at this loop, take 2, 2 into consideration. When you go from A to B, don't do everything at once. You will get confused. When you go from A to B, what is happening? When you go from B to C, what is happening? Do it in that. Okay. So this one I'm giving you 2 minutes time. Write it and show it to me. I want to check your notes. Even if it is wrong, I don't mind, but try. Edra? எடுக்கலாமே BDEB கூட எடுக்கலாம். இஷ்டம், எனக்கு நான் காம்ப்ளிகேட் பண்றதுக்காக தான் பெருசா. That's up to you. Once you gain experience, you take however you want. For me, I want you to write the equation for this. AB அப்படி வராது, ஏன்னா in ABC, in ABCA and DCAD, you didn't take this 5 volt into consideration. B2, no need of resistor. I gave this only to make you understand one thing. Inge resistor irukonu avashyam illa. So when you go from B to E and E to D, between B to D, actually there is no point E at all. I created it. It is B to D. What is there? You have a 5 volt battery. No, that's it. Shunt. அதெல்லாம் இப்போ தேவைடா. Shunt will come to that. அப்படி எடுக்க கூடாது. B to D, ஆனா you should not go in this direction. இப்படி எடுக்கணும். இல்ல இப்படி எடு. That is what I want. Or else I would have given you the loop as ABCDA ன்னு கொடுத்திருப்பேன் நான். நீ சொல்றது வந்து you see, I've seen 2 of them asking this question. They're saying, when I say B to BED, can I directly take BD now? You can take, when I take B to D, you can either come in this direction or you can come from B to C, C to D. If I wanted you to directly go from B to D via C, I would have mentioned it as ABCDA. But I'm saying I'm diverting the path because I want you to understand how to handle this voltage. See, this problem, okay, it is one such problem. What if in exam there is no other option that you need to consider something like this? You should be in a position to handle it, right? 5 எடுக்கணும். பட் ஆக்சுவலாக 5 தான் வரும். நீ அதை ஃபுல்லாக எடுத்தால் 5 தான் வரும். ஏன்னா இதுவும் பேரலல் இருக்கு. ஸோ அதே தான் வரும். பட் ஸ்டில் ஐ வாண்ட் யூ டு டைரக்ட்லி டூ இட் இன் தட். சொல்லுப்பா, அப்படியே சொல்றாரு, தைரியமா சொல்லுங்க. First, climbing the stairs now when you go from lower to higher. சொல்றேன். -482 +5. எதுக்கு 2 வாட்டி +5 போட்டிருக்கேன்? ஒரு வாட்டி தான் எடுக்கணும். ஒரு வாட்டி தான் எடுக்கணும். இல்ல, for 5 you made a mistake. நீ கூட அதே தப்பு தான் பண்ணிருக்க. See, when you're going from B to D, are you walking from higher to lower potential or lower to higher? Up higher to lower, it's minus, no? Down the stairs. That is only a mistake. நீ கூட அதே தப்பு தான் பண்ணிருக்க. -5. நீ ஷோமா இப்போ மாத்தினியா? பட் இப்போ புரிஞ்சதா? யா, இது பிளஸ் கிடையாது, மைனஸ். ஏன்னா you're going from higher to lower potential. இப்போ B higher potential இருக்கு. Look at the bigger line. The bigger line is closer to B. So அப்ப நீ B to D மூவ் ஆறனா you're moving from higher to lower potential. Higher to lower னா நெகட்டிவ் தானே? அதான் இப்ப சொன்னேன். ரெசிஸ்டர்லன்னா டைரக்டா பேட்டரி வச்சு டைரக்ட் பேட்டரியோட பொட்டன்ஷியல் டிஃபரன்ஸ் மட்டும் தான் எழுதணும். You should not multiply it with current and all. இல்லடா, எல்லாமே மைனஸ் இருக்கு பாரு. I told you, at least one should have a plus sign. So I made a mistake. Check it. இது என்ன I3 எதுக்கு வருது? டைமென்ஷனலி ராங் தான் இது. I3 வராது. ரெசிஸ்டர்ல கரண்ட்டை பத்தி கவலையப்படாத. BED வழியா வரும்போது இஸ் தேர் a resistor? இல்ல. அப்புறம் எதுக்கு I3 எழுதுறேன்? நாட் நெசசரி. அதை அடிச்சிரு. அண்ட் 5க்கு வந்து மைனஸ் வரும். அப்புறம் இங்க எதுக்கு 2I3 வருது? யூ டைவர்ட்டட் த பாத். -4I2 கண்ணு தெரியுது உனக்கு? -4I2 கரெக்ட். Clear with this? So I could see some of you making mistake. The reason I gave this only to clarify your confusion. I've seen most of you doing that mistake. I'll clarify it again. Listen to this carefully. So most of you have a confusion of what to do with this current when there is no resistor. When there is no resistor in that branch, don't worry about it. All that you need to do is, I'm repeating it again, listen to this carefully. All that you need to do is, how many resistors are there in that loop and how many cells are there in that loop. Okay. So if I take the loop ABEDA, how many cells are there? 1 cell. And how many resistors are there? 2. So you should get 3 terms. So when I say 3 terms, this 2 into I2 plus I3 minus I1 is considered as 1 term only. I've seen some of you splitting and writing it. Don't do that. Okay. So what you need to do is, when you go from A to B, first thing is you're crossing this 4 ohm resistor. So across the 4 ohm resistor, what is the current? 4I2 with a minus sign. Why minus? Because you're walking in the direction of current. So when you go from B to D through E, the meaning of BED means you're going from B to D through the E path, right? So when you do that, you're crossing the 5-volt battery. So 5-volt, you're walking from higher to lower potential. So it will be -5. And you're going from D to A. So it will be +4 into I1 minus I2 is equal to 0. This is the expression. Now, all that you need to do is expand everything, collect the terms, and then solve it. That's the mathematical part. I'm not getting into that. For me, the area of interest is to teach you how to write the equations. Okay, slowly with practice, you will be able to get it. But today I'm going to concentrate only on how to frame the equations. I hope it is clear, right? So now, those who are online, am I clear? Is there any doubt? Online, guys, any doubt?
No, sir.
Okay. So with this knowledge, let's solve this problem. So this is also a textbook problem. Determine the current in each branch of the network, which is shown in the figure. So there is a circuit of this format, and there is one cell and one resistor connected. So there is an exercise problem 3.9, page 128, I think. That one. Okay. Okay. So in this problem, if you see, there are only arrow marks given. Unlike the previous one, they didn't give you the values of current. So this problem, we have complete freedom to choose the constant, choose the variables that we want. So first thing, if you ask me, can I solve this problem using Ohm's law? Yes, we can do it. Right. These two are in parallel. These two are in parallel. These three will become parallel. That will be in series with this. Okay. Then you will be able to find the total current and then split and write it. That part we can do. But what I'm going to do now is, if I take the total current supplied by the battery as I, right? If I take the current to be I, at point A, the current is getting split into two parts as I1 and I minus I1. I hope by now you would have understood why it is I minus, right? So this I1 is entering here, so it will become I2. So here it will become I1 minus I2. Because the current is coming out. It's up to you. It's just a variable. Right? 1 minute. So here I will take it as I2, and here it will be I1 minus I2. See, it is up to you. If you want to take this as I2, you can take this as I1 minus I2. You will still get the same answer. Okay. So this I minus I1 is flowing towards, let's call the junction as D. So this I minus I1 is flowing here. I2 is flowing downwards. So they both will get added and go in the other branch. Is that not what is going to happen? So I minus I1 plus I2. So how much is it going to be? I minus I1 plus I2. I hope this point is clear. This is where I want you to concentrate. I minus I1 plus I2 is going here. I1 minus I2 is going here. So they both are traveling towards the junction. Then how much will be the current that is leaving the junction? The sum of these two. So when you do the sum of these two, I1 and I1 will get cancelled, I2 and I2 will get cancelled, you will get I. Meaning of it is, whatever is the current that is supplied by the battery will come back to it. That should happen. Okay, when you apply this KCL, if this is not happening, then you made a mistake in the division or the dividing or the adding part. You need to be careful with this. Okay, sometimes due to lack of concentration, sometimes instead of I minus I1, you will write it as I1 minus I. You will get stuck. So please check. Okay. So am I clear? So whatever is the current that is leaving from the battery should come back. That's with respect to KCL. Now what we need to understand is how to apply KVL. Before that, what are we supposed to do? I minus I1 is towards the junction. I2 is towards the junction. If you take towards the junction as positive, leaving the junction will be negative. So add them and put. Breathe. So first thing, when you need to apply KVL, what is that your eyes are supposed to look for? The number of unknowns. The number of unknowns will be the number of loops that you need. So how many unknowns do we have? I1 and I2. 3 unknowns, 3 equations. So 3 loops are needed. So for that, I will take the first loop as AB, DA. So when I go from A to B, I'm crossing a resistor of 10 ohm. So 10 ohm resistor carries a current of I1, but since you're walking in the direction of current, you take minus. Similarly, when you go from B to D, you get write 5 into I2. Since you're again from B to D, you're walking in the direction of current, write it as minus. D to A, it is going to be 5 into I minus I1. Since you're walking in the direction opposite the current, take a plus sign. This whole thing should sum up to 0. Make sense? Right? So this is one loop. The other loop that we can consider are BD, CB, and the other loop that we can consider is, I'll take this to be E and F. I will take the third loop to be AB, C, E, F, A. A, B, C, E, F, A. So I hope by now you understood why I took a bigger loop. Simple. I need a cell. Right? So based on this, quickly form the equations and show it to me. Now you should do it faster. That is my way. ஒருவேளை உங்களுக்கு வேற ஏதாவது சொல்லி கொடுத்திருந்தா you can follow that. I generally follow lower to higher frequency. உனக்கு ஆலன்ல சொல்லலையா? நான் ஷார்ட்கட்ஸ் மட்டும் சொல்லி கொடுத்துருக்காங்க. ஆரம்பிக்கலாம். is equal to 0 बोलो. Which one did you say? B? BDCP. Okay, minus 5/2, minus 10. Correct. Minus 10/1. Correct. Correct. Okay. So let me frame the equations. When I go from B to D, so it is going to be 5 into I1 minus I2. But since you are walking in the direction of current, it is a minus sign. Similarly, when you go from, oh, sorry, wait. I went in reverse, sorry. Correction. Yeah. So it is 5I2 with the minus sign. D to C is minus 10 into I minus I1 plus I2. From C to B is going to be plus 5 into I1 minus I2. This is 0. Is the point clear? So when you go from A, B, C, E, F, A, so A, B, C, E, F, A to B is going to be minus 10 I1. B to C is going to be minus 5 into I1 minus I2. C to E, you're crossing this potential source from lower to higher, so it is plus 10. And here you are walking in the direction of current, so it is minus 10I. Everything put together is going to be a 0. Is the point clear? So again, 3 unknowns and 3 equations. You need to solve them to find the answer. Clear with this? Right. So that part I'm leaving it to you. So if you're T, E, F la pathana, when you go from E to F, you're walking in the direction of current. Okay. Illada, 10, it is not a resistor. That is what I told you. It is not a resistor. Whenever you have a battery, you will directly write the potential difference. Simple, mate. This is dimensional. See, V is equal to IR. This is the dimension of potential difference. This is the dimension of potential difference. You can add two physical quantities only if they're dimensionally consistent. So that is why I'm not multiplying this 10 with I. If I do that, it is a mistake. Potential source never multiply it with current. Resistor mattuna current ala multiply. Okay. Clear with this? Those are online. Am I clear with this?
Yes,
Yes,
sir.
sir.
Yeah. So this itself took so much time, no? But yeah, see, this base is important. Now, let's look at the next important concept, that is relation between terminal potential EMF and internal resistance. So, if I take a cell with an internal resistance R, so if I take this end to be A and if I take this end to be B, let's say this end has a potential of BA and this end has a potential of BB. Okay. Now, what will happen is there are two scenarios. When you talk about a cell, right? When you talk about a cell, that cell can either supply current outwards, means it can supply energy to passive elements, or it can take energy from another cell. So if the cell is supplying energy, you call that kind of a situation as discharging condition. The cell is getting discharged. So whenever the current is flowing, away from the cell. You call it as discharge, right? So here, my job is to find the terminal potential difference, means the potential difference across the terminals of the cell, ends of the cell. So this has VA and this has VB. Obviously, positive terminal is on the leftward side. So VA will be greater than VB. So VA minus VB is what is called as the terminal potential difference. E is called as the EMF and R is called as the internal resistance. Okay. Now I'm going to show you how to apply Kirchhoff's law to this kind of a circuit. So when we talk about KVL, we speak about loops, no? But I'll tell you how to apply here. Listen to this carefully. So I'm starting from point A and I'm going to point B. So I'm traveling from A to B. So when I start from point A, the potential I have in my hand is VA. Right. So from VA, when I go to B, I'm encountering two elements. What are they? One is a passive element and one is an active element. So first I'm encountering a cell. So for the cell, I'm walking from higher to lower. So I'm going to lose a value of E. Whereas across the resistor, I am walking in the direction opposite to current. So I am going to gain a potential of I into R. So what did I do? I started with VA. I lost some potential here. I gained some potential here. And the resultant of all this is what I'm left out with at point B. So this will be equal to VB. So unlike a closed loop, what I'm doing here is I'm saying I start with something, I lose some, I gain some, and then I have the resultant at the end point. So that is when you travel from one terminal to another. Am I clear with this? Now, if I rearrange this equation, this VA minus VB means VB will come to this side. This E will go to the other side as plus E, and IR will go as minus IR. This VA minus VB is what is called as the terminal potential difference, is equal to E minus I into R. And this is the expression I have already given you. You're able to understand? So this is going to be the relation between the terminal potential difference, EMF, current and internal resistance when the cell is getting discharged. Clear with this? So in this condition, what will happen is the terminal potential difference will always be lesser than the EMF. So the terminal potential difference is always, sorry. So the terminal potential difference is always less than the EMF under what condition? Under the condition of discharge. Okay. So please make a note of it. So 10 minutes in your sudden battery at this other. Resistor external connect pannu. Internal resistance is offered by the electrolyte itself. वो नेतने class attend कर गया. The resistance offered by the electrolyte of the cell itself is what is called as internal resistance. இதுக்குள்ளேயே இருக்கும் பேட்டரிக்குள்ளேயே இருக்கிற ஒரு ரெசிஸ்டன்ஸ். இந்த பாசிட்டிவ் டெர்மினலுக்கும் நெகட்டிவ் டெர்மினலுக்கும் நடுவில் ஒரு எலக்ட்ரோலைட் சாரி, அந்த எலக்ட்ரோலைட் ஆஃபர் பண்ற ஒரு ரெசிஸ்டன்ஸ் தான் கால் இட் as இன்டர்னல் ரெசிஸ்டன்ஸ். பேட்டரிக்குள்ள இல்லை, அது பேர் இது மேல நான் சொல்லியிருப்பேன். இஎம்எஃப்ன்றது இட் இஸ் இங்க என்ன போட்டிருக்கேன், என்ன போட்டிருக்கேன். So, and the 1.5 volt is the EMF of this. It's not the potential difference. So, EMF is 1.5 volt, but இது ஒரு circuit connect பண்ணனா அப்ப இதோட potential difference குறையும். It will not be, ஒரு multimeter இல்ல voltmeter எடுத்து கனெக்ட் பண்ணா it will not show 1.5, அதை விட கம்மியா காட்டும். இது வந்து without any device, இதுல இருந்து எனர்ஜி எடுக்கலன்னா it is 1.5. யூஸ் பண்ணா it will be less. அதாவது அந்த யூசேஜ்ல இருக்கிற டைம்ல it will be less. Okay, those are online. Am I clear? Shall I proceed?
Clear, sir.
Yes, sir.
Okay, so we are going to solve a problem based on. So there is a battery of EMF 10 volt and internal resistance 3 ohm, which is connected to a resistor. Okay, so first let's try to analyze this circuit. There is a battery of how much EMF? 10 volt, and how much is the internal resistance of it? It has 3 ohm. Okay, then how are they connected? This whole system is connected to a resistor. If the current in the circuit is 0.5 ampere, the current in the circuit is 0.5 ampere, what is the resistance of this resistor, and what is the terminal voltage of the battery when the circuit is closed? Okay, so first of all, I will represent the battery like this. What does this mean? This is a battery with an EMF and internal resistance. So in this problem, they have already given you the current that is flowing. So if I concentrate on the second part, what is the terminal potential of the battery when the circuit is closed? Then V will be equal to E minus IR. Why did I write minus here? Because the cell here is getting discharged. How will you know whether it is getting discharged or charged? If the current is away from the positive terminal, you say it is discharged. Okay, so V will be equal to, what is the EMF? It is 10 minus, what is the current through the circuit? It is 0.5. So current through the circuit is the same current through the cell also. 0.5, that is half, multiplied with 3. So 0.5 into 3 is 1.5. 10 minus 1.5 is going to give me 8.5 volt. Means if you take a voltmeter and place it there and check, it will not show you 10 volt, it will show you only 8.5 volt. That is the meaning of it. Is that point clear? So that is the second part of the question. But what are we interested in? We are interested in calculating the resistance that has been connected also. Right? So if I observe, what I can do is I can simplify the circuit by treating this 3 ohm as a resistor in series with this capital R. Can I do that? When I do this, then the whole circuit will get converted like this. This will become a resistor of resistance R plus 3, which is connected across a 10 volt battery, which is carrying a current of half ampere. 0.5 is half. Okay, so one battery, one resistor, I can easily apply Ohm's law. V is equal to IR. So what is the value of V? 10 is equal to I is half into what is the external resistance? It is going to be R plus 3. 2 will go to the other side. It will become 20. So this 3 will come to the left hand side. It will become 20 minus 3, which is going to be capital R, and R is equal to, so the external resistor that you have connected in this problem is 17 ohm. Is it clear? 8.5 எடுத்தா அப்ப டைரக்டா 6 ன்னு எழுதிடலாம். அப்ப நீ என்ன பண்ணலாம்னா see if at all you want to solve it another way அதுவும் நான் எக்ஸ்பிளைன் பண்ணிடுறேன். ஃபர்ஸ்ட் இதை காப்பி பண்ணிக்கோ, I'll explain that also. அதுவும் நான் பண்றேன். ரைட். ஆஹா, எப்படி வேணும் இருக்கு. இந்த ப்ராப்ளம்ல அப்படி இருக்குன்னா ரைட். Okay, I'll just show you an alternate way to solve this problem. Okay, so the alternate way is what I did is I treated this internal resistor as an external resistor and took it as series. What else is what is the other thing that I can do is this battery of 10 volt and 3 ohm internal resistance can be treated as a battery of 8.5 volt. Why is it so? Because we have already proved it. Right? It should be 8.5 volt, which is connected across this resistor capital R. And how much is going to be the current? The current is still going to be half ampere. Apply V is equal to IR again. You apply V is equal to IR. V this time is not 10, it is 8.5. Is equal to current is still half and resistance is capital R. So capital R will be equal to 8.5 into 2 is still going to give you 17 ohm. It's the same. So however you do, you should get the same answer. Whichever you are convenient. So I'm saying both are correct. Whichever is convenient to you, you can take. Okay. What is the time? Can you give me 10 more minutes? Can I take? Okay. I just want to teach one more concept. Shall I proceed? So the next part is charging condition. So what do I mean by charging condition? That is when you have a cell with internal resistance. If I take this to be A and B, the cell has EMF E and the internal resistance as R. Here the potential is VA and here the potential is going to be VB. Okay. So you can say that the cell is getting charged when the current is flowing towards the positive terminal. Right? So I'm going to apply the same Kirchhoff's law. I'm starting at point A with a potential of VA. Right? I'm crossing the cell. Across the cell, I'm walking from higher to lower. So I am losing a potential of E. Right? And across the resistor, I'm going from higher to lower again because I'm walking in the direction of current. So it will be minus IR. This will be equal to VB. So I started, I lost, and I'm left out with the value at VB. So VA minus VB in this scenario is going to be E plus I into R. So V will be equal to E plus IR, and this is the condition or the relation between terminal potential, EMF and internal resistance when the cell is getting charged. Okay. So in this case, what will happen is the terminal potential difference will be greater than the EMF. It will be greater than the EMF. Just give me a minute. Okay. I'll solve a problem based on this, and I'll give you time to write. So it's a concept here. It's the same logic as what I did in the previous case. Yep. அப்படியே கேளுடா. இதுவா இல்ல என்ன டவுட்? இல்லடா நான் ஃபர்ஸ்ட் டைம் தரேன்னு சொல்றேன். I'll finish the problem then I'll give you time. Okay. So let us do a problem that is based on charging a battery. Okay. So if you look at this question, there is a storage battery of EMF 8 volt and internal resistance of 0.5 ohm. So there is an 8 volt battery which is connected across, which has an internal resistance of 0.5 ohm. If you observe, it is charged by a 120 volt DC supply. So I have a 120 volt DC supply. And if you observe one thing here, whenever I say something is getting charged, the positive should be connected to the positive. Listen to this carefully. Okay, I'll show you how these work. See, for example, if I take these two batteries, okay, so this has a positive and a negative terminal. This has a positive and a negative terminal. If I take the positive of the first and connect it to the negative of the second, then I can say that these two cells are connected in series. Listen to this carefully. If I do the reverse also, I can still call that they are connected in series. Okay, but what is the difference that we need to observe here is, when I take this positive terminal and connect it to the negative, what happens is the current supplied by this battery is in this direction, because current is supplied from positive to negative. It goes like this in the circuit. What about this one? It also goes in the same direction. So both the currents are complementing each other. They're supporting each other, so that if I look at this battery, this is 1.5 volt and this is 1.5 volt. The system acts as a 3 volt battery. Whereas if I take the positive and connect it to the positive, like how it is happening in this problem, what will happen is this will supply the current in this direction and this will supply the current in the opposite direction. They get nullified. So this 1.5 volt and this 1.5 volt put together will not be 3 volt this time. Rather, it will be, so when you are connecting it like this, they are not going to be 3 volt, rather it will be 0. So what is the point I want to stress here is, whenever you connect a positive terminal to a positive terminal, the currents will be in opposite direction. Hence, the effective EMF that is going to occur, the net EMF that is going to occur in this scenario is not going to be 120 plus 8, rather it will be 120 minus 8. Is that point clear? Why is it so? Because they are supplying the currents in the opposite direction. This will supply the current in the leftward direction. This will supply the current in the right. This will also be in the leftward direction, but here it will be anti-clockwise and here it will be clockwise. They are in opposite direction. They get cancelled. So in the example that I explained, I took similar batteries. That is why 1.5 minus 1.5 was 0. Here, they both are of different values. It is 120 minus 8. Is the point clear? So 120 minus 8 means it is going to act like a 112 volt battery, which is connected across a 0.5 ohm. Right? But listen to this. This 120 volt DC supply using a series resistor is there, no? So what is happening is, there is a series resistor of how much that is connected? 15.5 ohm that is connected in this problem. So what will happen is, this 120 and 8, they get nullified and they become, they get cancelled and they become a 112 volt battery, which is connected across a resistor of 15.5 plus 0.5, which is going to be 16 ohm, meaning the new circuit will look something like this. So here I'm not considering which is internal, which is external and all. I'm only looking at them like series and parallel. So it is like a 112 volt battery connected across a 16 ohm resistor. If I take the current to be I, then I will be equal to V divided by R. V is how much? 112 divided by R is 16, and the answer will be 7 ampere. So in this case, the current that is going to flow through the circuit will be 7 ampere. Why did I find the current? Is because if you see in this question, they are asking what is the terminal voltage of the battery during charging. So V will be equal to I into R. Sorry. I'm sorry. V will be equal to E plus I into R. What is the value of E? So here they're asking what is the terminal voltage of the battery. That is where the question is very important. They're saying storage battery of 8 volt and this is a 120 volt DC supply. So which one should I take as E? I should take 8 because that is what they're calling it as battery. So 8 plus I is how much? 7 into what is the current? Sorry, what is the internal resistance? 0.5, which is going to be half. So the answer will be 8 plus 3.5, which will be 11.5 volt. So in this case, the terminal potential difference is greater than the EMF. Are you able to understand? So this will be the terminal potential difference across this battery, right? And they're asking what is the purpose of having a series resistor in the charging circuit? Logic is very simple. To control the amount of current that is flowing from the supply battery to the storage battery. If that was not there, you directly connected, there would have been heavy possibility of this device getting damaged. So to control the amount of current, we took it. Is the point clear? So please make a note of this. Previous slide. You're done with this slide, tell me. Other cells in parallel. E by R is equal to E effective by R effective is equal to E1 by R1 plus E2. And the next katra. If we're done with this, we can wind up. So those who are online, is it clear?
Yes, sir.
Okay. So we can wind up, guys.
Thank you, sir.
Thank you, sir.